Welcome to today's LinkedIn Live. My name is Kelly. I am the Solutions Director for the Enterprise Markets at IDWave, and I am joined by special guests and friends of IDWave, Peter Cappiello, CEO of Future Technologies, and Gary Hill, Chief Information Officer at Future Technologies. And today we're here to discuss private networks and ROI. For those of you who are listening and don't know Future Technologies, they're one of the leading system integrators who have been working in private networks. Peter, you've been doing it for many years, but these days I think you're tackling some of the largest and most complex deployments probably out there. In our LinkedIn Live today, we're going to discuss a few exciting topics. We're going to talk briefly about what we're seeing in the market for private networks and the challenges of ROI, the challenges in general. Gary, he's at the Living Live Lab Live and is going to give us an exciting tour of their lab where they showcase various private network technologies, pretty cool stuff they have going on in there. And then Peter, we're going to chat about one of your recent car manufacturing projects. Rumor says that is one of the largest private networks deployments done globally today. So thanks to both of you for joining us, and thanks to everyone live joining us on LinkedIn. Do feel free to drop your questions in the comments section. We'll do our best to ask a couple as we go, and then more towards the end. Peter, you're going to be doing your best to multitask and converse in the comments section as well. No pressure now that I've just announced that to everyone. But all right. So let's, Peter, talk about the market a little bit first. I think I read a report recently that has the private networks market growing up to about 21 billion in 2030, which is about a 60% growth from where we are today. Pretty significant, I would say, especially I would say after the growth we've been seeing the last few years in private networks. I know when I look at the market and what we're seeing at IDWave, there's a clear trend kind of in certain verticals that are really leading the way for that growth. The early adopters, and then you have other verticals now kind of crossing over that adoption chasm, and that's where we're seeing the growth. So certainly we saw it a lot in mining the last couple of years, and then more of those industrial kind of enterprise verticals, manufacturing, transportation, logistics, and then some that are maybe more a little bit behind but starting to grow are education and healthcare verticals as well. A lot being driven by industry 4.0, IoT, all the smart things, right? So that's kind of what I'm seeing in the market. Maybe you can share what you're seeing at Future Technology. You guys are on the ground, where your project is going to happen.
Yeah, no, I think that's a good read in the market. We've been in the network transformation business for 25 years, but specifically for private cellular, we've been in the private cellular market for about 15 years now, starting in the DoD space. So we were doing actually, believe it or not, 2G and 3G private networks, and in those initial deployments, we were augmenting traditional land mobile radio to provide voice and data. So for the last 15 years, we've been doing that. Kind of fast forwarding to today, we have seen mining, and we've participated in the mining market back into 2017, 2018, 2019. And we saw autonomous haulage being one of the driving use cases that provided the ROI for the network. And then, connected worker after that. So it's kind of, one anchor OT use case and autonomous haulage, and then connected worker. Honestly, we've kind of shifted our focus vertical market wise, where if we look at big containers, we see military as a big container. We have about 2,500 square miles of private networks built out in the DoD space right now. We see energy as a big container, and then kind of subcategories: digital oil field, chemical, and then also even carbon capture. It's a little early in the market there, but we have some active deployments in the carbon capture space.
Okay.
Transportation, to your point, is also a market, with maritime ports being early adopters in that space. But one of the largest projects that we've done is actually in the manufacturing vertical with a Fortune 100 client, where we have an actual live project. The scope of it will be about 5 million square feet at totality, and the anchor use case, the providing the ROI is AMRs, autonomous mobile robots.
Okay, nice. That's lots of good momentum going on there, sounds like. And for you, what are you kind of the biggest challenges you've seen, I guess, enterprises to adopt the private networks? I know for us, there's hesitation to kind of spend on cellular, especially coming from a little bit more of a Wi-Fi centric market in the enterprise, right? And also with that is maybe a learning curve that comes along with learning about the technology. What are some of the challenges that you're kind of seeing?
I think we're starting to see the market move a little bit because I think as an industry we're getting better at educating the client in terms of what the technology is able to do,
Hmm.
and changing the narrative from 5G can do everything to 5G does certain things that are additive,
Right,
and it's not to replace your legacy networks, it's to add an incremental network to do some specific things like provide coverage, provide capacity, provide control, or in certain situations, provide the connectivity needed for an advanced use case like AMRs. And I think education and having good information get to the enterprise so they can make informed decisions. I think 3 years ago when we were at a different phase of the hype cycle, I think the information was not as clear. So that's the first part, and then the second part is, and we'll highlight this later on in our case study example. But some of these, when we talk about advanced use cases, it's complex. So we have to,
yeah,
be able to model. In some cases, we have to do modeling for a building that doesn't exist. There's a lot of big
right,
manufacturing being onshored in the chip market, in the EV market, and these large, greenfield manufacturing environments. They need next generation connectivity, but we literally have to model before the building's built, which is a a challenge. But
right,
I think if you have the right amount of experience, you can apply that, do conceptual, and then as you walk through the project. In this case, we did about 30 designs from V1 to the final, and then after we're done delivering the network, we do quite a bit of optimization to activate an advanced use case like AMRs. But it's not for the faint of heart. These
right,
are important networks. They have to be running. There's density. There's a lot of technical parameters we have to make sure that we get right. Our team
yeah.
did a great job, and looking forward to talking about that later.
Okay, awesome, thanks. And what do you think are some of the key drivers that will kind of continue to grow the adoption of private networks going forward? Um,
Yeah, I think the stability of the product category is helping us do that. But we see different. Uh, for us, it's kind of obvious. So if you look at a chemical site, with Wi-Fi, you might be able to cover 60% of your operational environment, but with private cellular, you can cover 100%. So immediately you get connected worker, you can build some
yeah,
efficiencies, you can enhance the safety, and then as you go from there, which are fundamental things that you need to work in a hazardous workspace, you can get into industrial automation or even robotics. So we see those things, and then in some other areas, like that's a dense environment. We see some coverage opportunities, like in the digital oil field, where there is no mobile networks out there. So
right,
we're building out coverage mobility networks to allow for the digital oil field. But inside the four walls, where we use the IB Wave tool to do modeling, it's very focused on advanced use cases. The client has a wired network, they have a Wi-Fi network. We're adding a private 5G network for advanced use cases and using the IB Wave solution to basically plan those advanced use cases and have them work in a collaborative way with the other technologies. In a lot of cases, we're using Wi-Fi as the backup connectivity for
right.
advanced resiliency.
Yeah, makes sense. So speaking of use cases, I know that you guys have this Living Labs tour, and you showcase some of these use cases in the lab, which I think is really exciting. I've seen a sneak peek of it myself. So I think let's bring Gary into the picture now, and we're gonna take you guys actually to the Living Labs from Future Technology. So, hey, Gary, welcome. Just maybe to start, mind introducing yourself and giving us some context about what you do at the Living Labs and what kind of the goal and the purposes of the lab there, and then take us on a tour of what you have.
Yeah, thank you, Kelly and Pete. Again, Gary Hill with Future Technologies. My role is Chief Innovation Officer, so I spend time looking kind of at the front end of our engagement process of kind of what's possible with networks, use cases. Obviously, we have a lab environment demonstrations for our customers. So that's my role here. Been here a little bit over 4 years. My background is in industrial manufacturing. Worked for Georgia Pacific Coke Industries for about 30 years running their global IT. So today we're going to go through our living lab. It's a part of our headquarters near Atlanta, Georgia. So again, we have a combination of our headquarters space, we have an active warehouse and a lab, and we call it living because one, we're constantly changing it. And you're going to see here in a moment too, is our lab is embedded within the facility. So it's not a white coat lab, it's not PowerPoint, this is real networks. We're broadcasting multiple types of networks here, private cellular, LoRaWAN, Wi-Fi, and we're running real use cases. So look forward to showing you our capabilities. Again, the value is this lets us show customers kind of those networks and the use cases integrated together. I mean, one place, we don't have to go build a test network for a customer. We can bring them here to really see those networks, educate them. As Pete mentioned, there's still a lot of education for enterprise customers with the 5G network. So again, a great place to see it all and have really great discussions. So we're going to start in our edge compute room on our tour. So we're running a couple of our private networks here in this lab. We're also running here in this middle rack Intel server, so a lot of edge compute here. A lot of our applications run at the edge, some are in the cloud. Pete mentioned IB-Wave. That's one of our key tools as we do network design and optimization. So this rack here is hosting that software. Part of that is, again, predictive design, kind of heat map of what a network might look like. Again, very, very important. Those tools let us kind of determine coverage area, how many radios are needed, kind of what direction they're pointed. And again, after an implementation, we can come back and drive that network, walk that network, gather data, and come back and really do then optimization with the tool. So again, really important, the design phase, the tooling, and the optimizations where IB-Wave really is key, kind of our end-to-end processes. Show you a couple of private networks. So here in the lab, we're running Nokia, Ericsson, we run Salona. So again, we're fairly neutral on private networks. A lot of customers want different, maybe OEM type solutions. Here's the Nokia Indac. So this is our lab system running band 48 CBRS. We also have other edge compute. We're running software. So one of the use cases is computer vision. So here's a stack of Intel compute running computer vision AI software where we're streaming cameras into that software. This is the Ericsson EP5G system. This is a 4G, 5G dual core. Actually, we're broadcasting you today from an iPhone. So we're using N48 5G spectrum, band 48. So this is the EP5G system. We're going to go out into our lab. Before, I want to kind of show you some of the radios. We often get asked the question, well, hey, what do these radios look like for a private network? And for indoor, they look a lot like a Wi-Fi access point. So here's one. Here's kind of another form factor, a dot, but again, kind of small. Again, these cover probably 5 to 8x of a Wi-Fi access point. You're going to have fewer of them, but the form factor is very, very similar. You get to the outdoor coverage, mounting those radios on towers. So again, these are a little more robust. Here's an example of an outdoor radio that we done on a tower. And then of course you're mounting antennas for your directional coverage. So again, we like to show people, physically what these things look like. We're going to go into our arena area. This is where we have a couple towers with the radios broadcasting. This is also where we do our use case demonstrations. So swing out here. First thing we're going to do is stop at our tower where the radios are broadcasting. So Zach, you can pan up here. Here's one of the 2 towers that we have in the facility. So kind of go from the top to the bottom. We're actually doing point-to-point microwave. So we still do a lot of microwave in the industry for long distance backhaul. As you come down, there's a couple of the dots for CBRS spectrum. We're broadcasting private cellular. There's also a Wi-Fi 6 AP. So again, as Pete mentioned, we're integrating to a customer's existing network. So Wi-Fi is not going away. Wired is not going away. So we kind of have all these technologies. We have cameras. You see a camera on the tower. So we're doing streaming of cameras in the environment, wired and wireless, because some of the use cases we look at really are taking advantage of streaming cameras. As you come down, here's like a LoRaWAN IoT gateway. So LoRaWAN is really a pretty great product, a solution for IoT sensors, very long distance for the sensors, battery operated. So again, kind of a flavor. And again, we can have all these integrated. So I can get on a device on a Wi-Fi radio, talk to a device on the private cellular. So we really pre-integrated this network here in the lab.
Hey Gary, That's a good point.
Yeah,
Today we're talking about private 5G, but I think it's an important part of our engagement with the clients that we recognize they have multiple types of connectivity there,
Yeah.
that's
multiple
right.
types of devices. And from a practicality perspective, you've done a great job building like a real world environment. And the customers, I think, enjoy that versus, again, what I said earlier, 5G can do everything. We think we need to use all of the capabilities the client currently has, and then even in the case of LoRa, and sometimes that's a better fit for IoT applications. But you know, I think that resonates really well with the clients. You've done a great job putting that together.
Yeah, thanks, Pete. Yeah, because our goal is to solve the customer's problem, right? So they have some opportunity to solve. So again, we're applying all the networking technologies to that, and we're going to come up with the best solution for them. So as you can see here in the lab, we also have use case tables. So down the left and right, so various use cases. It could be devices. We have some applications that we run. We also have a stage up front, so we do events in here. We're actually having our annual tech summit here next week. So if you're in the Atlanta area, look us up on the internet and come join us for the tech summit event. So again, let's just quickly browse through some of the use case tables. We don't have time for demos. This table here represents some of the Nokia UE's devices. So devices are very important. Once you have a network built, you're going to make sure the devices, handhelds, industrial routers, do those connect to that network. So I do a lot of validation testing of really a lot of UEs. So not just Nokia, but all the different vendors, Apple, you got Zebra type devices in the warehouse environment, a lot of Android devices. So we do extensive testing. So again, these are industrial handhelds. Here's even an industrial 5G camera that can do wireless streaming. Some industrial routers. There's again one of those indoor access points. You saw one of the kits we had in the lab, more of a rack mounted system. This is a portable network, so we can actually take this private network. It's a band 48 CBRS network. We can actually take this on the road, trade shows, customer locations, bring that up. So as long as we have like a cellular internet connection, we can make that connection and be broadcasting private cellular really anywhere we want to. This is another example of industrial routers. So this is going to be called Semtech Sierra. They make an extensive line of industrial routers. The reason I highlight this is a lot of the use cases in industrial settings, a lot of those devices you're connecting to, maybe cranes, equipment, a lot of those obviously don't support native cellular connectivity. So most support Ethernet or serial. So what these devices let me do is bring that industrial piece of equipment through Ethernet, through serial, onto a router, and then put that on the private network. So again, very important as we look at industrial use cases. A lot of these devices, again, can't speak cellular natively. This is a table here showing some use cases around connected worker. This is, I say, one of the more predominant use cases as we're building private networks. What are people doing with those? And this is really showing, iPad, iPhone, RealWear headgear, even Microsoft HoloLens, of people putting these devices on their new private networks. To give you an example, in big chemical facilities, we're putting outdoor macro coverage covering acres of the facility. In the past, really, those companies had no connectivity in those areas. So today, they're able to now put a worker with an industrial tablet, put them out in the chemical site, looking at work orders, doing things that are productive, so they don't have to come back to their desks. So again, you have that going on. This also is another example of computer vision. So here's the 5G camera. We have the software here running on a little Nook Intel computer at the edge. I'll just bring up the interface very quick to let you see what that looks like. Again, we're streaming cameras wirelessly. So right here, here's the actual 5G camera we're streaming. So Zach and I standing here. This is a simple AI application of it's identifying people and doing people counting. So again, you can point this camera at an environment, run through those models, do people detection. You can even do things like in an industrial environment, are people wearing their safety gear? So I can train that model to look at an employee and tell, are they wearing their hard hat, safety goggles, many things you can do with computer vision. Let's pan over here to another industrial application. This is an autonomous mobile robot. So you're seeing a lot of these in factories, logistics, warehouses. When COVID hit, a lot of the workforce couldn't come to work. So many companies started taking these autonomous robots and really putting those into their warehouses. So this particular robot is a Mir 100, pretty popular unit. Almost all these today are natively Wi-Fi. We're seeing a few vendors start moving towards private cellular. The use case that Pete will share later is a company that their robots run native 5G. This one, though, we took an industrial router on the back of it, and basically interface it to our network to show customers what's possible. So I can run this on Wi-Fi. Today, this is running over 5G on the industrial router on the back there. So again, it's about showing what's possible. Hey, maybe a little bit less sexy. This is a fork truck. So this is maybe companies that can't afford to upgrade their logistics to AMRs, maybe making their fork trucks a little more connected. So here's a scenario of, hey, we have a Sierra 5G modem. I'm connected to the 5G network, have my tablet connected, also have a Wi-Fi bubble that I can connect my Zebra scanner to this to get on the 5G network. So again, this is software that can direct people where in the warehouse to go pick things. Even on this particular one, the driver can see the autonomous robot. So I may have an environment that has the combination of fork trucks and AMRs. So now the driver can kind of see the scenario. Again, with the 5G bandwidth we have, they can also view cameras in the facility. So again, connected fork truck, a lot of possibilities there. Hey, I'll mention GE Vernova. They've been around a long time. They do a lot of industrial routers as well around, private cellular, 4G mainly, some 900 megahertz. But again, oil and gas, energy industry, you'll see a lot of GE industrial routers. So again, we have these here to kind of demo and do use cases with those customers. One more item here we'll just show. We mentioned IoT. So here's an industrial IoT vibration package looking at vibration on industrial motors to predict downtime. And then this is our IoT platform. We've got a variety of IoT sensors here, talking to a LoRa gateway, going out to the internet. Then we can kind of do monitoring of, hey, is there issues with temperature? Is there leakage? So again, a wide variety of use cases. So again, that was a quick tour kind of our facility. I hope you get a flavor of kind of what we can do. We also let customers bring in their use cases. So obviously we can't demonstrate everything. So some customers bring in their use case, put on our edge compute, use our networks to do validation and testing. But really, these are the types of things that are really driving that end value for enterprise customers. Yeah, the private network is great. We have to have it for that connectivity, but it's really a means to support these use cases that really drive the business value through automation and through driving efficiencies.
Hey, Gary,
so,
one quick question for you. I mean, you spent 30 years on the client side, VP of IT, CTO, Georgia Pacific. You've been with us for 4 years, on this journey with us trying to make private networks practical. What do you think the biggest takeaway is from, being on this side, learning, if you're on the enterprise side, what do you think one thing they should take away from this?
Yeah, probably the biggest thing is that I've just experienced it. Cellular technology, private and public, is different technology. Most enterprises are not used to managing cellular technology. So I'd say, one, find a good OEM and then find a good partner. Again, we do a lot of education teaching, so we can come in and help an enterprise learn the technology, do the design, and then they can start managing it and maintaining it. So one would be, study the cellular technology. There's this thing called spectrum that you have to deal with, of either licensed spectrum, unlicensed. So again, that's another consideration kind of as you're a buyer of this technology. So
and the spectrum plays into the design and all that. And I guess we're gonna talk a little bit about our manufacturing project, but no, we appreciate it, Gary. Thank you for your time and doing the tour.
Yeah, thanks
Peyton,
Gary.
Kelly. Thank you.
Some really neat stuff you guys are doing in that living lab. It's really cool to kind of see the AMRs and the forklift truck and everything live. So that's neat. Makes it more real. All right. So Peter, you just mentioned the car manufacturing case study. So let's jump to that topic. Maybe I know that this was a massive kind of deployment that you guys have been working with a Fortune 100 company car manufacturer about, and you have some slides, I think, to kind of walk us through that project a little bit and talk about maybe the design of it, some of the challenges and whatnot. So I'll let you take it over.
Yeah, that's great, Kelly. And we'll be time conscious. I know we got a little bit of a late start, but just for context for the viewers, we identify as a lead system integrator. We've been in the business for about 25 years. We're based out of Atlanta, Georgia. And, we've been working in the private network market or private cellular market for the last 15 years. Again, we're focused on these vertical markets, manufacturing, transportation, military, chemical, oil and gas, and utility. Today we're going to highlight a Fortune 100 manufacturing case study example, but just to show that there is momentum in the private cellular market, we wanted to highlight 6 different case studies across utility, chemical, oil and gas, ports, and then also Department of Defense. Um, the audience can review this in after the event, but wanted to make sure that it's clear that we are getting to at scale in terms of private 5G adoption. On the DoD side, we have 2,500 square miles deployed. We've got multiple ports in major metropolitan centers deployed. We recently just won a $5 million deal in the Western U.S. So there's definitely momentum in the market. But to get to our topic at hand, we competed on a global tender with a Fortune 100 client about 15 months ago. It's for a new EV factory that at totality will be 5 million square feet. And we're very proud that not only we won it, but we actually have this network up in production now. We're using a private 5G standalone solution. We're using a Nokia private 5G core, a Nokia N48 radio access network solution. And then in addition to the RAN and the core, we're also using an edge solution from Nokia to provide some advanced capabilities with a domain proxy and local SAS. For anyone that's familiar with the US market and you're using GAA spectrum, we find that using a local SAS helps build resiliency. So we're using that from Nokia as well. The use case we talked about earlier, initially it's autonomous mobile robots, and with that it integrates into the industrial automation strategy of the client. We provided some example visuals on the right hand side, being that this customer is not named. These are not the customer specific sites, but it gives you an idea of the scale of a manufacturing site, the scale of the robot. We're talking about large robotics that are carrying vehicles and parts, so they're fairly large in scale. Whereas the one that we showed in our facility is kind of smaller material movement robot. So to get to the specifics in terms of like where IB Wave and our interests align is when we get a large project like this, we have to look at a lot of inputs. So is the network uplink or downlink centric? In this case, it's uplink centric. What's the latency tolerance? We needed to have low latency, so using 5G SA was our preference there. Mm-hmm. We do private 4G LTE networks. We could see sub 50 millisecond latency. In this case, we needed a tighter specification than that. The throughput requirements was high. It's an advanced use case. The type of network is a mobility network. One of the things that differentiates private 5G versus Wi-Fi is the handoff capabilities of the network. Has to be engineered in a very specific manner, and then you have to optimize and tune and make sure you have your neighbor lists. But and that kind of plays into the next component, which is the density. A lot of times the industry is focused on the throughput and the latency component, but the industry does not speak about density enough. This is a high density deployment in terms of robots per square foot, and it's also a very dense, industrial setting. So when we're planning it, we have to make sure that we have good source data in terms of the drawings of the facility. And then as we get into real world, we have to optimize our renderings to take into account other obstructions and things like that. Very detailed exercise that our team does a great job of. Mm-hmm. In this case, clients using an industrial router. So we are ultimately designing for a link budget between the radio access network and the user device. And because of the nature of this project, it's mobility. So we have to have good handoff. We have to have good resiliency. We also, one of the things that you have to think about is that some of these robots are actually carrying a vehicle. And, so it takes designing it into a whole nother level, because you actually have to factor in potentially some loss because of the obstruction of the vehicle actually sitting on top of the robot itself. And we try to, as a system integrator, we try to design based upon conservative. We'd rather set like a modest expectation than outperform. Our team is very focused on defining the problem statement, working through that. In this case, we did about 30 iterations of the design. It's our first, large scale EV factory. As we've entered different vertical markets, it's important for us to keep our brand. So we invested, a few extra 1,000 hours into the design. But the outcome you can see on the right hand side, we have an initial, base design. And I'm sensitive to our clients' information, so this is just like a snapshot. But you could see that as we went from an initial base design, 30 iterations of additional conceptual designs, and then ultimately optimizing the network, you could see that we designed it well, and then delivered it even better. A real credit to our engineering team and our partner Nokia working with us, because you really have to get into the details of the right planning, the right inputs, the right requirements, partnering with the client, how many robots are going to be in which area at what time. And it really takes a team effort, and then also it takes having a good software tool to do the simulation on. But we're very proud of this network and the engagement with the client and Nokia, and we're looking forward to more complex projects like this. I mean, this is definitely what we're focused on.
Yeah, awesome stuff. I mean, that seems like a super complex network to design. So how long does a project like this take you guys typically, Peter?
Yeah, so we received the award in Q4 23, and we just delivered the network here in the last couple months. So the totality of it, we're now waiting for the other buildings to be built, but the initial phase of it is where the client's ready for us. We're done with, and we have a couple hundred robots on the network now, so we feel pretty good that the recipe's working.
Okay, awesome, good stuff. Maybe take a couple questions I see coming in here from the audience. So one is there a private to public network handshake with this design?
No, I mean, the nature of this, and we could ask those questions, and there are some technical solutions coming in for what we would call that like a hybrid network. So do we have a network that's private network and public? We do some of that on the DoD side. The robots aren't leaving the plant. So in this case, we designed for a private network only, because the robots are going to be captive to the environment. And that's also ultimately what's driving the return on investment. To go to the topic here, as the client adds other, ground devices, so maybe they add scanners or tablets or user devices. We have a different project that we recently did in New York City area with a large port. We're connecting 300 lift devices, so big cranes and things like that, to move containers around. That was the reason for the network, and then the customer added additional ground devices after. But that's, again, a private network. Those devices are OT centric. They're staying there. On some of our military projects, we have we're using MORAN, where we have a private network being broadcasted, and at the same time we have a public network being broadcasted, because that client needs that type of solution. So we're able to do that, but in this specific site, it's a private network only.
Okay, great, thanks. Question from Brian is, are you monitoring and managing the network on behalf of the customer, or what does that look like?
Yeah, so we've taken the approach of designing, furnishing, building, and then we try to identify clients that want to own and operate. So I think it's worked. Our pipeline has grown 400% year on year. But to be specific to the question, we're partnering with our different enterprise and military clients in a model that they can use capital dollars. They can basically monitor it themselves, do level 0, level 1. We provide level 2 support, and then we leverage the OEM for level 3 support.
Right.
We do have some customers that are trying to twist our arm into doing monitoring and NOC. But we partner with a lot of companies that also offer those capabilities. So we're being somewhat careful to focus on what we're good at, what our clients want from us, and that's our approach right now.
Okay, great. Thanks. Question around the AMRs. I think you said there was around 100 on the network right now. Um, is there
Yeah, there's
any
about
other
200 on the network.
200?
It's going to scale to 1,000 AMRs at total production.
Okay. And is there any other UEs or CPEs on that network? Just AMRs?
The having the advanced connectivity to provide for that use case provides the customer with ample ROI, and that is the basis of the investment. They are looking at maybe adding things, but they want to make sure that this is this is number one. And if they add any other devices, it's supplemental. They don't need it to justify the capital investment.
Okay, great. To me, one question I have is, for enterprises maybe that haven't started to use private networks, what's the best way for them to kind of get started in a way that allows them to see short-term value, but sets them up maybe to scale in the future as well? Any insights to
Yeah,
offer there?
I think our motion is like, we engage the client, have them understand what's possible using, the living lab, but then
Yeah,
we try to find a production site where there's a production site with a real problem, and it could be basic as like, connected worker, it could be an advanced use case, but let's find a production site. We don't need to prove 5G works, right? It's more of
right.
how does it work in your environment? How does it integrate into your stack? How do we handle
Yeah,
security? So, you know, uh, learn what's possible, and then find a production site where if we together identify the right use case or use cases, we can put that into a production environment, get the stakeholders to buy in. Because once you show that it works, it then the gravity takes care of itself. But I think as an industry, a couple of years ago, people were doing labs and about what's possible in the future with a
yeah,
question mark. I think going back to a practical approach of, making sure that it's tried and tested, but, going into a production site, showing real, business outcomes, even if it's, let's say we have a 500,000 square foot, site, maybe we take 50,000 square feet so that the initial investment is smaller. But if you could prove it
yeah,
out in 50,000 square feet, you could then scale it up to the total facility. We think that's a better use of money for everybody. We don't really make money on lab systems. We make money partnering with clients to solve real problems,
yeah.
and we would like to, help them do that.
Awesome. And maybe just being conscious of time, we just have one more minute. So maybe I'll end it on this note. How do you see private network kind of evolving from here? What's in store for private networks for the next 5 to 10 years? How does it get better?
I think, for dedicated private networks, we have a pretty good playbook, and we're scaling
Yeah,
that. I think that, what we're looking at in 2025, 2026, there's a big opportunity in the in-building market. There's a lot of legacy 4G systems that are out there, and we see it as a twofold opportunity to go do a tech refresh and provide public network connectivity, but then also in mixed use or industrial settings, provide a private network. And we're looking forward to help those clients, in that transformation, and then also working with our partners in the marketplace, whether it be a carrier, an infrastructure partner. But there's hundreds of millions of square feet in the United States that's going to be modernized, and
yeah.
we intend to do a lot of it.
Awesome. Well, sounds like you've already got a good start to that. So I think that brings us to the end of this LinkedIn Live. So a big thanks to you, Peter, and you, Gary, for joining and sharing kind of what you guys are doing at Future Technologies. It's all really great to see and pretty awesome stuff, honestly. So thank you. And thanks to everyone who joined us on LinkedIn. There is a recording of this that will be available, I think, on our LinkedIn page as well as on the IBWave website.